In this video, we will study encoding part in linear block code chapter. So first we will say we will understand the meaning of linear block and code. So code, first we will see what is code. Code is a set of code words. Then what is block code? The block code means the code words in that set are of same length. That is block code. Okay. So let us understand these two words, code and block, from this example. So this is a code 6, 3. So it is a set of code words. How many code words are there? There are 8 code words. I have not written in between code words. I have just written first, second and 8th code word. So code is a set of code words, or it is a group of code words. Now each code, this is one code word, this is second code word, this is 8th code word. Now each code word here is of same length. What is length? Length means number of bits in that code word. So here the number of bits are 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Likewise, every code word is of 6 bits only, and that is indicated by here n. That is n equal, n is 6 here. So code word is of length 6, which is called block length of that code, So this is block code. This is a code which is a group of code words, and each code word is of same length, so it is a block code. Okay, so you might have understood the words block and code. Now let us understand some other terms. So here 6 is called n, that is and n is length, block length of that code. That means how many bits are there in every code word. What is 3? 3 is from 3 bits you are making the code of 6 bits. From 3 bits you are making a code of 6 bits. How? You are adding some parity in that 3 bits and making it 6 bits. So 6 is block length of that code. 3 is message word length. Message you are giving, or the input is of 3 bits and output of that code is 6 bits. And this is over Galois field 2. So what does this means? This means that the components or the elements in each code word is either 0 or 1. If it is Galois field 3, then element or the elements or components in that code word will be either 0, 1 or 2. If it is Galois field 4, it could be 0, 1, 2, 3. Likewise. Okay, so how many code words are? So this is a group of code words. So let us see how many code words can be there in that code. So number of code. So here there are 8 code words. So how that is calculated? 8. That this is a group of 8 code words of length 6. So that is calculated by 2 raised to 3. So number of code words in that code you can calculate by seeing what is Galois field, how many elements are there in Galois field, how many numbers are there in Galois field. So in Galois field 2 there are 2 numbers, 0 and 1. In Galois field 9 there are 10 numbers. 10 no? Galois field 9 numbers, 0 to 8. Galois field 10 there are 10 numbers, 0 to 9. Likewise, so you have to make 2 raised to 3 message word length, 3 bits. So 2 raised to 3 is 8. So number of code words in that code is 8. So number of code words in the code is given by q raised to k. That is Galois field q is this one. So 2 raised to k is 3. So what till now what we have seen? We have understood the meaning of the words code and block. Code means group of code words. Block means what is the length of each code word, and how many code words are there in that code. That is decided by k and q. q is number of elements in the Galois field, and k is number of bits of number of message bits. So how code is formed? Code, you give the input, that is k, to the code. It gives you the output c, which is of higher bit length than the message bit length, because parity is added in 3. Why parity is added? To detect the errors that can happen during the transmission. So for that you are adding extra bits. Such likewise code is formed. Now what is linear? Now let us see what is linear. So linear means, this is a set. So first condition is that there should be all zero code word. So here there is a all zero code word. Second condition is that if you add two code words, then the result will be again in that group. If you add this and this, the result will be again amongst these 1 to 8 code words. Then third is minimum Hamming weight. Minimum Hamming weight of the code is equal to minimum Hamming distance of the code. Minimum Hamming weight of non-zero code word is equal to minimum Hamming distance of the code. So to understand that, you should know what is Hamming weight and Hamming distance. So Hamming weight is number of non-zero elements in the code word. So we are now concentrating on only Galois field 2. Okay, so that's why now number of non-zero elements in the code word, or number of zeros, number of ones in the code word. So if this is the code word, how many ones are there? There are 3 ones. So Hamming weight is 3. Now Hamming distance. Hamming distance is number of places the two code words differs. So if these are two code words, you write down first code word as 10110 and second as 11011. So how many bit positions they are different? So here they are different, here they are different, here they are different. So 3 places they are different, so that is 3. So that is Hamming distance. In linear block code, if you compute Hamming distance between two code words and write it down, the minimum Hamming distance between two code words, then that will be equal to Hamming weight of the Hamming weight of the code word. Minimum Hamming weight of the code word. Minimum Hamming weight of the code word. What is minimum Hamming weight? That is of non-zero code word. If you take code word 0 and say that its Hamming weight is 0, so it is minimum. It's not like that. You have to skip this 0 and you have to start from this and find out the Hamming weight of every code word. So and note down the what is minimum. So that minimum Hamming weight equal to minimum Hamming distance of the code. So it is time consuming to compute minimum Hamming distance, because you have to do permutations and computations depending on how many number of code words are there. But finding minimum Hamming weight is not time consuming. So that is advantage, that in linear block code, if you find the minimum Hamming weight, so you can take it as minimum Hamming distance. But once again I am repeating that minimum Hamming weight of non-zero code word. So this is the background for linear block code. So let us move to the problem solving. So for 7,4 linear block code, this is the generator matrix. The questions are similar, only the generator matrix they will change here. This is fixed, they will change here and ask you to find all the code words. So commonly asked are 6,3 and 7,4. So this is 7,4. So what you have to remember, how many columns are there? Columns are 7. How many rows are there? Rows are 4. So 4 is rows and 7 are columns. 7 is n, 4 is k. So 4 message bits and you will get 7 code word bits. So 3 parity bits are there. 3 parity bits are there. So first you have to see whether it is in standard form. Generator matrix is in standard form. So this you can see that generator matrix in standard form, you have to by heart this one. I, K, P, K into N. It is very easy to by heart also. I, K, P, K into N. What is IK? It is the identity matrix of dimension K. What is K? 4. So you can observe that here is the identity matrix of 4 by 4 is there, and P is parity matrix. So don't remember its dimension. And dimension of generator matrix is K rows and N columns. So 4 into N, 4 into 7. So let us find the code words now. I have randomly selected these message words. It's very easy method than whatever the methods I have taught already in colleges also. So I was going in very lengthy process, but I just found this method, and this is very simple, as well as it is not time consuming. So listen carefully. First you have to check whether it is in standard form. So it is in standard form. Okay, after that, this is a message. It is of 4 bits. Yes, K is 4, so message should be of 4 bits. So you have to take this message 1101 and generator matrix. This is the generator matrix. Now you have to label where are the ones in the message words. So ones are at first, second and fourth bit position. This is first. We are considering this as first. So first, second and fourth. So after that there is no part remain of this message word. After that you have to select first, second and fourth row of the generator matrix. There is no play of this. You have to just label. For labeling how many which rows you have to select, you have to use ones of where are the ones in the message word. So first, second and fourth, you have to add these rows. So first, second and fourth rows are added. Now addition is also very easy. You have to just count odd ones. If odd ones are there, write 1. If even ones are there, write 0, because this is XOR operation. So 1, even 0, even 0, 1, 0, 1, 1. So this is your code word. Okay. Let us take another example. So it is 0 triple 1. So you know that you have to add this and this row. So same is written here. So again, even 0, odd 1, even 0, 1, 1, 1, 0. This one 1 0 0. So there is only one. So take the first row and write it as a code word, because there is no another row for addition. 1 0 1 0, first and second row. Again 1 1, even ones are there, so 0 0, odd 1 1, 0, odd 1 1. This is your code word. And in systematic, if the generator matrix is in systematic form, then first you will get the message word 1 0 1 0, and after that parity bits. Last is this one, triple 1. So you have to add all the rows of the generator matrix. So odd ones 1, again odd 1 1, again odd 1 1. So this is 1, again odd 1 odd 1 odd 1. So this is your code word. So let us take 6 comma 3. So 6 comma 3, 6, n equal to 6, k equal to 3. Generator matrix, see whether it is in ik, pk into n. So ik. So that is this is your ik. So 3 by 3, k is 3. So 3 by 3 identity matrix, then parity, and the dimension of the generator matrix is k into n. 3 rows and 6 columns. So it is in standard form. So you will get the systematic code, where the first you will get the message word. After that you will get the parity word. So this is called parity block. Many times they give the parity block also. So the message word 0 0, code word is 0, 6 zeros. If message word is 0 0 1, 0 0 1. That means you have to write the last row of the generator matrix. So 0 0 1 1 1 0. If message is 0 1 0, then 0 1 0 1 0 1. If message is 0 1 1, so you know that you have to add this and this. So the addition will be 1 1, then 1 plus 1 0 1 1 and 0. So if 1 0 0 1 0 0, that means you have to write the first row. Then 1 0 1, you have to add first and third row. First and third row of the generator matrix. So 1, this is 0 1 1 0 1. So if it is 1 1 0, 1 1 0 means you have to add first and second row. So first and second row of the generator matrix is written here, and addition is even 1 0, odd 1 1, odd. So this is your code word. Then triple 1. So triple 1 means you have to add all the 3 rows. So same row of the generator matrix. So they are written here. So even 1 0, here 1 1 even, so 0, here 1 1 even, so 0, here 1 odd, so 1, here 1 is odd, so 1. Number of ones you have to count. Here number of ones are odd, 1, so 1. So answer is 1 1 1 0 0. Now you will form the table like this. That message word is this one, that code word is like this. So you have to write here the weight, which is called H, Hamming weight. So here you are not considering this one. So here 3, number of ones, 3 3 4 3 4 4 and 3. Now amongst these, what is minimum? Minimum is 3. So this minimum Hamming weight is minimum Hamming distance. So minimum Hamming distance is 3. So why that is necessary to find the minimum? So you will get to know that how many errors this can detect and how many errors this can correct. So this code can detect d minimum minus 1, that is 3 minus 1. So this code can detect less than or equal to 2 errors. How many errors it can correct? That is less than or equal to td by 2, that is 2 by 2, that is less than or equal to 1. So it can correct less than or equal to 1 errors. So this is the encoding part of the linear block code. Now you take your textbook and solve number of problems like this, and you know that in textbook you will get much more problems, but solve by this method and see the answer in the textbook. And if once you practice this much, so in the exam you just only see one example, and you can solve any example in the exam. So this is very simple method. Still now I come across, because before I try to do the multiplication bit by bit, but that is a very lengthy process. So this I find very good. So after that, in the second part, we will see the encoding and encoder diagram of the linear block code and the syndrome decoding. So this is part 1. So in 2 parts the chapter will be finished. So still in your university there are different problems. You can just comment about that, so that we will try to cover that also.